Hello everyone and welcome back to our channel. This week we are going to be tackling a request for a vector and matrices problem. This time from the June 2021 past paper exam. So without further ado, let's get into it. Okay, so we are going to be looking at question 10 of this past paper. 10A Part 1 asks us to calculate the matrix product of these two matrices here. Now we cannot calculate the product of any two matrices. The dimensions of the matrices need to be compatible. What do I mean by that? Okay, let's take a look at it. So this first matrix here, what is its dimensions? This would be a 2 by 2 matrix. How did I get that? Because it has two rows, 5, 4 and -3, -2. And it also has two columns, which we see in the vertical dimension here. So let's look at this matrix on the right hand side. What is its dimensions? So it would be a 2 by 3 matrix because this one has two rows this time, but it has three columns. Okay, so what do I mean by compatible matrices? By compatible, what I mean is that these two numbers in the middle must be the same. These two numbers here, 2 and 2 in this case, they must be equal in order for you to be able to multiply these two matrices. And an interesting fact is that when you multiply the matrices, your resulting matrix is going to have the dimensions of 2 by 3. So this is a helpful way to look at it. So if I know my resulting dimensions are going to be a 2 by 3 matrix, I could sort of just construct my 2 by 2 matrix here. I am just doing it like this, where I'm going to perform my multiplication. Now, when you are multiplying matrices together, you always multiply a row by a column, and you do it one at a time. And every time you multiply a row by a column, you'll get a single number as your answer. Okay, so I have a I did like a 2 by 3 table here where I have two rows, one on top of here, two rows, this one and this one, and then I have three columns here because I know that my final product, my final matrix is going to have the dimensions 2 by 3. So let's start with the first multiplication. As I mentioned, it's going to be a row multiplied by a column, and I'm supposed to get one number. So what you actually do is you multiply the corresponding values and you add them together to get the resulting answer. Okay, so let's look at just the first item in this final matrix that we are trying to make here. So I have to multiply 5, right, because I'm multiplying this first top row here of the column on the left by the first column on the matrices on the right hand side. So 5 multiplied by 2 plus 4 multiplied by 0. And what does that give me? That gives me 10. Because 10 plus 4 by 0 is 0 and 5 by 2 is 10. So I'm getting 10 as my answer. So that's my first answer here. This is the first element of my final matrix. So now we're going to do the same thing for the top row on the left matrix and the middle column on the right matrix. So when I do that, I get 5 because I'm multiplying the corresponding value. So this is 5 by 1, the first number in the row by the first number in the column. And I'm adding that to the second number in the row, which is 4, by the second number in the column. So that is 4 multiplied by 3, and that gives me 5 plus 12. So my final answer for this particular element is 17. So let's get this element in this block right here. So to get this, I'm multiplying again my top row on my left matrix with the third column in my right matrix. So multiplying the corresponding values again, I'm multiplying 5 by -4, and I'm adding that to 4 by 6. So what does that give me? So 5 by -4 is equal to -20, and I'm adding that to 6 by 4, which is 24. And what does that give me? This gives me 4, because -20 plus 24 is 4. So now let's look at the bottom row of this matrix that we are trying to get. So now that means I have to look at the bottom row of my left matrix and multiply that by each of these columns in turn of my top matrix. So let's start with the first column. Bottom row of left matrix multiplied by first column of right matrix. So I have minus 3 by 2, again because I'm multiplying the corresponding elements. So first item in the row by first item in the column, right? And I'm adding that to minus 2 by 0. So what does that give me? I'm getting minus 3 by 2 is minus 6. And of course, anything by 0 would give you 0. So my answer here is minus 6. What about the middle value? So let's look here. So we're going to be multiplying now the bottom row of the left matrix by the middle column. So to do that, I'm getting minus 3 by 1 plus minus 2 by 3. And that gives me minus 3 by 1 is minus 3 because we're using BODMAS, so we have to do the multiplication first before the addition. And plus minus 2 by 3 is minus 6. So minus 3 plus minus 6 is equal to minus 9. So now we are going to look at the final element of our matrix, which is formed by multiplying the bottom row of the left matrix by the final column of my right matrix. So that would give me minus 3 by minus 4, and I'm adding that to minus 2 by 6. So again, let's do each of these multiplications separately. We have minus 3 by minus 4, which is equal to positive 12 because a minus by a minus would give you a plus. And then I'm going to be adding that to minus 2 by 6, which is minus 12. So this is 12 minus 12, because these two things, it's a minus, and that gives me 0. So then I have my final answer here. So my matrix, therefore, I'm just going to separate it here. My answer would be a matrix, a 2 by 3 matrix where my elements are 10, 17, 4, minus 6, minus 9, 0. And that's the answer there. And then we actually have already answered part 2 of this question, which asks us to state why the two matrices are conformable for multiplication. The answer to this is exactly what we talked about at the beginning of the part A1, which is that these two numbers here match, which is that the number of columns in the first matrix is equal to the number of rows in the next matrix. So these two inner numbers here match, and therefore they are compatible. For part B of this question, we are asked to determine the inverse of this matrix. Now, if we were to call this matrix A, the inverse, which is written like this, is equal to 1 over the determinant of A multiplied by the adjoint of A. Now we're going to talk about each of these terms separately, right? So let's just kind of look at a general matrix, a 2 by 2 matrix, right? If we give letters to each of the elements in the matrix so that it's A, B, C, D here, the determinant of this matrix is equal to AD minus BC, which is exactly what it sounds like. You just multiply A by D, whatever elements those are, and you subtract the product of B by C. And what about the adjoint of A? The adjoint of A is even easier. It just involves flipping these two values so that you just switch the locations of A and D, and for the other two you just make them negative. So what that looks like is that you have D up here and A below here, and these other two values remain in place except you put negative signs in front of them. So this is your adjoint of A, and we have our determinant of as well, right? So the adjoint of any matrix would be this. So let's go back to the problem that we have here. So what is A? So in this case, A is equal to 5, B is equal to 4, because you always write the information that we're given before you try to work out anything. C in this case is minus 3, and D is equal to minus 2. So let's first find the determinant. So the determinant of A here is equal to AD minus BC. So let's work this out. A is 5. We're multiplying that by minus 2. And then we are subtracting BC. And BC in this case is 4 multiplied by minus 3. So let's simplify that. 5 by minus 2 is equal to minus 10, because a positive by a negative would give you a negative. And then of course we have to minus this because this is the same sign we have in the middle. And then we are working out this product here, 4 by minus 3. 4 by minus 3 is equal to minus 12. Now a minus and a minus, if you recall, will give me a positive. So this would work out to be, I'm bringing it back over here, minus 10 plus 12, right? And what does that work out to be? That's the same thing as 12 minus 10 if you flip it around, which is equal to 2. So we have the determinant. We now need to find the adjoint of A. And how do we find the adjoint of A? We find the adjoint of A, as we talked about before. We have our matrix, but instead of leaving 5 here and minus 2, we're going to flip these two values on this diagonal here, so that the minus 2 is on top and the 5 is at the bottom. And the other two values remain in place, but instead we make them negative. So the 4 becomes negative 4, and the minus 3, it's already negative, so it will become positive, because a minus and a minus would give you a plus. So now we have adjoint A and we have determinant A. So now we can apply what we know about finding the inverse, which is this equation up here. So let's do that. So the inverse of A would be equal to 1 over 2 multiplied by, because that is the determinant of A, we've already found this up here, multiplied by the adjoint of A, which we find, which is right on top here. So that is multiplied by minus 2, 3, minus 4, 5. So how do we do that? Well, it's a half multiplied by all of the elements within this matrix. So that's all we do, is apply a half to each one. So we have minus 2 over 2, minus 4 over 2, 3 over 2, 5 over 2, right? And then we just simplify this. So this would give me minus 1. 4 divided by 2 is 2, but because of the minus sign, it becomes minus 2. And of course, these are fractions. We're just going to leave them as fractions. And there you have it. This is the inverse of this matrix A. And then we just simplify this. So this would give me minus 1. 4 divided by 2 is 2, but because of the minus sign, it becomes minus 2. And of course, these are fractions. We're just going to leave them as fractions. And there you have it. This is the inverse of this matrix A. Okay, so for part C of this question, we're given a diagram here which consists of several triangles that are connected by different vectors. Okay, so they're asking us to find, for part 1, CD. CD would be this vector here. I'm going to put the arrow to show that it's going from C to D. So what is CD equal to? Well, CD is equal to CA plus AD, not so? CA plus AD. So let's write that down. CA plus AD. But they asked us to express our answer in terms of R and S. So how do we do that? Okay, well, let's look at the information that we are given. We are told that OA, which is this entire vector here, is equal to R. And we are also told that OC, which is just from here to here, is equal to 3/4 OA. So if OA is equal to R and OC is equal to 3/4 OA, then that means that OC is also equal to 3/4 R, right? So let's put that in a diagram here. So this is equal to 3/4 R. So if this whole thing is R and this part is 3/4 R, then CA is equal to 1/4 R, which is just from right here to here. So we have already found here that CA is equal to 1/4 R. But we still need to find AD. So let's look at AD. So AD is equal to 2/3 of AB, right? Which is the information that we are given up here. But can we express AB in terms of R and S? Because remember, our final answer needs to be expressed in terms of R and S. So let's take a look at that. How do we get AB? So AB can be, you can get AB if I go from A to O and then I go from O to B, then I get from A to B, not so? All right, so then AB is equal to AO plus, so I'm going from A to O and then OB. So AO, let's look at that one. So AO is from here to here. So if you look at it, this is going the exact opposite direction from O to A. AO would be equal to negative OA, which is R. So instead of R, AO would be equal to minus R because it's going in the opposite direction. And remember, with vectors, the direction matters. All right, so we have AO is equal to R minus R, and then we have to add S. So this is what I get. So this is the same thing as S minus R. So now we've expressed AB in terms of S and R. So, but again, we're just looking at AD because that's the next part of your vector CD. Because remember, at the bottom here, CD is equal to CA plus AD, right? So we already found that CA is a quarter R. So now we know that AD, if AD is equal to 2/3 AB, then that is the same thing as 2/3 by S minus R. Okay? So AD is 2/3 by S minus R. So we're going back to the original thing, equation that we had here. We are trying to find CD. So we know CD is CA plus AD. And now we have AD as well. So that is equal to 2/3 by S minus R. But can we simplify this a little bit further? Yes, we can. How do we do that? So I'm going to rewrite this. So instead of a quarter R, I'm saying R over 4. It's exactly the same thing. Plus, I'm multiplying. Now I can expand these brackets. What do I mean by that? I mean that I need to multiply what's on the outside, which in this case is 2/3, by everything inside the bracket. So I multiply 2/3 by S. So let's do that. 2/3 by S. Let's just write it like this. Minus 2/3 by R. I'm putting minus because there's a minus sign in the middle here. So 2/3 by R will give me 2R over 3. So can we simplify this? Yes, we can, because if you look, this term has R and this term is R, and we can put all the like terms together. So I'm going all the way to the left here now. So I have R over 4 minus 2R over 3 plus, of course, my 2S over 3. Right? So if I were to simplify this, I were to add this. It's a simple addition of fractions. So of course, you'd find the LCM, which is 12. 4 and 3. So 4 into 12 is 3. 3 by R is 3R minus, because there's a minus sign in the middle. 3 into 12 is 4. 4 by 2 is 8R. And then, of course, I have 2S over 3. Well, I'm just doing this at the bottom here. So let's carry it across here now. So let's simplify this. Can I simplify this any further? 3R minus 8R is equal to what? Minus 5R over 12. So what I get here is minus 5R over 12, and I'm writing it like this now, plus 2/3 S, which is the same thing as, you can just flip them around, 2/3 S minus 5 over 12 R. So this is just, I'm separating this because this is just how we work this out. And our final answer here for CD would be equal to this, which is expressed in terms of S and R as the question asked us for. Okay, so for the second part of part C, I'm going to scroll on so that you can see they're asking us to find OE. They're asking us to find the vector OE. So let's take a look at this. How do we do this one? Okay, so I'm going to work it out to the left up here. So again, we are trying to find OE, And I just rewrote the information that we just found at the bottom here, that CD is equal to 2/3 S minus 5/12. So they're asking us to find OE. So let's draw a line connecting these two, and it's OE, so the arrow would be facing that way. How do we find OE? So OE is equal to, you can see clearly that you're going from O to C and then from C to E. So let's write that, O to C plus C to E. But again, remember, we need to write these in terms of R and S. So let's look at OC. Do we have that already in terms of R and or S? Yes, we do. We know that OC is equal to 3/4 R. So now we just need to find CE. So how do we do that? If you remember, the question also told us that in addition, they said E here is the midpoint of CD. So that means E is smack dab in the middle of CD. So if we know CD, which we do, because this is what we found up here, CE would be exactly half of that. So let's write that. CE would be half of CD, right? It would be half of CD. And that is equal to 3/4 R plus half of 2/3 S minus 5/12 R. So let's simplify this. So let's bring down the 3/4 R, and then if you multiply a half by 2/3, then the 2's would cancel, so I'll be left with 1/3 S. And then if I multiply a half by 5/12, I'm bringing only minus sign because there's a minus sign here, and then a half by 5/12 would give me 5/24, and of course R. Okay, so now just like before, we're going to put the like terms together. So we have 3/4 R minus 5/24 R. So let's write it as 3R/4 minus 5R/24, which is the same thing. It's just easier to see it's easier to picture it when we are adding the fractions. Okay, so now of course we have 1/3 S. I just rearranged things a bit. So now we find our LCM. The LCM of 4 and 24 here would be 24. So let's start with the left hand side. 4 into 24 is 6. 6 multiplied by 3R would give me 18R. 24 into 24 is 1. 1 bring on the minus sign, of course. 1 multiplied by 5R is 5R. Okay, and of course we have 1/3 S. So 18R minus 5R is what? 13R. 13R/24 plus 1/3 S. And there we have it. We have OE now in the most simplified expression that is expressed in terms of R and S. And that brings us to the end of this question. Thank you for watching, and we hope to see you back here next week.